any query regarding the truss design, connection design, or regarding the table of forces, any question from design part, so he can ask me one by one. So yes, Uzair, please ask your question.
सर वो ये कुछ बच्चों ने पूछना था और मैंने भी सर जिन्होंने
Okay, Uzair, listen to me. So all the questions should be in English so that
sir.
all the foreigners can understand. Yes, please ask question.
Sir, we want to ask that those students who have prepared a member design on Excel, they should transfer it to Word or they can submit the Excel file?
No, they should not submit the Excel file. So if they want, actually, they need to submit a report. So on report, at least they should have some manual calculation of maybe at least 5 to 6 different members. And also they need to send me their Excel file also, because I want to verify whether it is plagiarized or not. Because many students, as per my information, they are just taking the Excel file from the other student and just put their data, so they don't are doing any work. So I will have some forensic analysis whether they have made the Excel file by themselves or they have just taken the file from the other student and just changed the values and are submitting their work. So I have to make sure. So I need
yes, sir.
design of at least 2 compression member, 2 tension member, and different member maybe. So at least 5, 6 member. Their design calculation must be reported in report. Word report. Okay.
Okay, sir. Sir, we can do manual calculation for some of the members, like you are saying that 2 compression and tension. Similarly, for stress reversal, but all members which we have designed on Excel, we will send the Excel file for them.
Yes, but again, the student who will provide the more calculation will have the more benefit. You understand me?
Yes, sir. Sir, but actually we don't know at the start. We have prepared the Excel sheets for all the members.
So Excel sheet is for just for your reference. It cannot be used for all things. So I know that how many, because when I will take the Viva, so I will open the Excel sheet in front of you and I will ask the question from the Excel sheet how you have come up with the data and how
yes,
you have
sir.
used different symbols. If any student he will not be able to answer, so he will simply get F. Do you understand me? So sometimes
Yes, sir.
convenience it is maybe causing trouble. Okay.
Sir, but
Because
many
I
students
used to
have
take
prepared
normally a very
themselves.
tough one. I have to verify this. That is
Okay, sir. Okay, sir.
on my end, at my end, how I will judge them there. Okay. So many students they have
Okay.
made themselves, but the most of they are not. Okay. You understand me? So I know this.
Yes, sir.
Anybody else who is having any question? Anybody else? Any question? So, so any student, just Jawad, please ask the question. Jawad,
वो जो इंटरनल मेंबर्स है ट्रस्ट के इंटरनल मेंबर्स, वहां पर डबल एंगल लग सकता है या नहीं लग सकता अगर वो लाइटेस्ट आ रहा हो तो?
लग सकता है. So I told you that the interior member, diagonal member, maybe they may be single angle, single channel, or double angle, or maybe double channel. Only out of these 4 options, whichever will be the lightest one you can use. Okay. You got the answer.
Yes, sir. Okay, हो गया.
Okay. Anybody else? Okay. There is one curious. One student he asked me the question regarding the modified ratio. Actually, please listen to my comments very carefully. So modified slenderness ratio will only be computed if we are connecting 2 members with stay plates and with snug tight connection. Whenever the 2 members they are connected with stay plate using the snug tight connection or bolts, in that case, because the boards, they are not tightened by by pre-tensioning, because they are just being tightened by full effort of a single person. So the level of the tightness may be different in different boards. So in that case, if the member is bending about minor axis or weak axis, so there might be some slippage. So in that case, you need to compute the modified tenderness ratio. There are two cases where you don't need to compute the modified tenderness ratio. What are these two cases? If stay plate is welded with the member, both members, maybe double angle, double channel, or if we are using high tension or fully tensioned bolt, then in that case, we are not having any possibility of the slippage between the connection. So in that case, maybe you can avoid or you can ignore the modified tenderness ratio. But if in the examination, if I have given the problem that the built-up section, in built-up section, stay plate is connected with the member by using snug tight connection, then only in that case you need to compute the modified tenderness ratio. Otherwise, you do not require. If you are using the welded connection with stay plates or fully tightened bolt. Yes, Uzair, what is your question?
Sir, in the book, he has provided the formula for modified standard ratio for welded and pre-tensioned members connectors also.
Yes, yes, yes. That's why I always said that you need to compute it. Because welded sometimes they also have some issue, because what happened? Because the stay plate, it is not used throughout the length, because stay plate is intermittently provided at 2 and 3 places. So what happened? Because most of the members, they are unconnected. So in that case, you also need to compute the modified tenderness ratio. Okay, in basic understanding, you just memorize one comment only. If you are using the built-up section with stay plates, you always need to compute the modified tenderness ratio. And if you are using lacing, then you do not require, because for example, when we have designed the built-up section with stay plates, so you might have computed the A value. So what was the A value? It was the length of unconnected portion corresponding to single section, and it was maybe 1.3 meters. So it means that the member within the length A, it can buckle individually. So it's because the member is not connected thoroughly, so we will not have the fully composite behavior. So it means that we always need to compute. In case of lacing, modified tenderness ratio is not required. But in case of the stay plates, we will always compute the modified tenderness ratio. Okay, Uzair, thank you for the correction. Okay. So you got that? You got the my response or the reply? That okay. Anybody else? Maybe Uzair might have some internet issue. Yes, Jawad, please ask the question. Jawad Ahmed Khan.
सर ये जो अब हम असाइनमेंट कर रहे हैं इसमें हमारी मर्जी है चाहे लेसिंग लगा लें चाहे स्टे प्लेट्स लगा लें
नहीं 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 you have to use the stay plates. Lacing कब लगाते हैं? ये question that could be one question in the quiz or in the paper. So actually, when we started the built-up member design with lacing, so in lacing distance between the member is very large. In case of the stay plates, the distance between them just equal to 10 mm gutter plate. Mostly, the member with stay plate is designed when we just need a built-up section for the strength criteria to meet up, because a heavy section was not available and we just combined two lighter sections to make the area equal to the required area. But with lacing, actually with lacing, we designed the built-up section for slenderness ratio, for the stability criteria, because strength check is always okay, because applied load is very less. And for the applied load, we require very less area. But the member length is very large. So if we are computing the slenderness ratio KL over R, so it means that length is very large. To reduce the slenderness ratio less than 200, we need a larger radius of gyration, or minimum larger. So how we can increase the radius of gyration? By placing the two member at larger space. maybe around 100 millimeter, 200 millimeter. So in that case, we cannot use this template, because if the gap between the two sections is 100 millimeter, it means that we require a stay plate whose thickness is 100 millimeter. That will be very heavy. So it means that just to avoid the extra weight and for the economic consideration, we are using the lacing. So lacing, in case of the lacing, so the both members, they are connected with a lattice pattern by a flimsy or thin plates, and the built-up member with lacing is mostly it is manufactured or designed to increase the movement of inertia or to reduce the slenderness ratio. You got the answer? You understand, Mr. Chan?
Yes, sir. Yes, sir.
That could be one of the question in the quiz. So where we prefer the member built-up member with stay plate, and where we prefer the built-up section with lacing, and what is the basic difference? I could ask this question in the quiz, or maybe in one short question in the paper, or maybe in Viva post examination. So anybody else is having questions, please he can ask. Okay, just I want that raise the hand all the students who has completed the table of forces. Who has completed the table of forces? Only few, or maybe they are not present at the moment. So I'm also sharing my screen so that all students they can see that. Okay, how many students they have already carried out the member design, truss member design? Okay, please remove your raising hand option. All the students are requested to remove the raising hand option. Please, all students, please remove your raising hand option so that I could ask some further questions. Okay, now my next question is that only raise the hand those students who have started the welded connection design also. Only 3, 4, 5. Only few. Okay, gentlemen, I'm giving you the deadline because on midterm exam, your date sheet, I think, has already been shared. So on the day of your midterm exam, for steel structure, I believe that you are having the very first exam, steel structure. You need to bring the complete design report with you. So that is a deadline. If somebody is not bringing a design report, so maybe he will not be able to make this subject, maybe pass this subject, okay? So please, I guess your exam will be on maybe 2nd of the February. So date sheet has already been shared on the notice board. So your design calculation, complete truss design, what it must include, I have already discussed some basic terminologies, and panel load calculation, member force calculation, design of the purlin, design of the roof sheet, and you must have the welded connection design and a summary of your design. Yes, Mr. Farhan. Farhan, what is your question? Please ask. Farhan. Farhan, do you have some question? Yes, Uzair, what is your question, Uzair?
Sir, we will submit in soft form or hard form?
Hard form, hard form, hard.
Okay, sir.
Okay, listen to me. You will also take the print of your Excel file, and all the students who have done most of the calculation on Excel, they will also send me their Excel file also by email, or I will ask them to copy in Dropbox, okay, something. So they need to provide me the evidence of their soft files. And also you need to submit your report in hard form, properly compiled report. It may contain table of contents also, okay, in proper order. So if there will be no any question, then I am starting my today's lecture. Okay, thank you. Good. So any question? Yes, Hassan Ali, please ask the question.
सर वो ये पूछना था सिंगल एंगल के लिए अनइक्वल लेग भी यूज कर सकते हैं हम डिजाइन में मेंबर्स के लिए इंक्लाइंड मेंबर्स
अगर वो टेंशन मेंबर है तो यूज कर सकते हैं, अदरवाइज नॉट।
सर टेंशन
Okay,
के लिए
there
तो
is one
बिल्ट अप नहीं हमने
clarity.
जो टॉप कोड मेंबर्स है जी सर
फॉर इंटीरियर मेंबर बता रहा हूँ ना, इंटीरियर के लिए, ठीक है। ओके, फॉर बिल्ट अप सेक्शन you will always double angle, always use the unequal leg. You understand? If you are using single angle, then that should be equal leg.
सर अगर हमारे केस में अनइक्वल लेग लाइटेस्ट हो तो फिर भी नहीं यूज कर सकते।
मैं बता रहा हूँ कि वो उस केस में यूज हो सकता है अगर वो टेंशन मेंबर है, इफ इट इज सेटिस्फाइंग ऑल द क्राइटेरिया। If it is the compression member, then I'm not recommending. In case of the compression member, I believe equal leg will be the lightest one. You understand?
लेकिन सर वो की थी ना तो एक मेंबर में वो अनइक्वल लेग से थोड़ा सा लाइटेस्ट आ रहा था तो इस वजह से थोड़ी कंफ्यूजन थी।
आप दोनों ठीक है नहीं वो कोई बात नहीं, आप दोनों को रिपोर्ट कर दें, लिख दें, because after your midterm you will have the 3 week for psychomotor analysis. So you are having 3 week in on campus classes. So during that week I will explain in detail regarding the member selection design. Okay, आप दोनों इक्वल एग अनइक्वल एग दोनों को रिपोर्ट कर दो, ठीक है, फिर उसके बाद हम इस पर डिस्कशन कर लेंगे। So principally what I believe, okay, principally if for the tension member design we may use unequal leg angle section, because in tension member design we need to control the tenderness ratio maybe less than 300, but in case of the compression member, so what I believe that equal leg will be most preferable section. But anyhow, you can report both, we can discuss later on if I will check it. Yes, next. Anybody else is having question? Anybody else? Okay. Should I ask the question or should I directly start the lecture? So just raise the hand who want that I should not ask the question. Okay, Hamza, what is your question? Hamza, please, yes. Hamza, ठीक है, मुझे पता। हाँ जी बताएं हमजा, मैं सुन रहा हूँ। हाँ जी हाँ जी L1 length of the connection is the longest weld. Okay. वो डिफरेंट मुझे समझ लगी उसकी, फिलहाल आप उसको कर लें, वो थोड़ा सा फार्मूला चेंज हुआ है, ठीक है, तो वो फिलहाल जो फार्मूला हम इसको रिवाइज कर लेंगे दोबारा, फिर मैं मुझे पता है वो फार्मूला लिटिल बिट डिफिकल्ट है, so I will discuss this formula maybe in my next lecture, but at for the time being you should use the same formula 1 minus x bar over L. I know the formula has been changed 2 years back, it has been updated, we will discuss in the next lecture, that's not a big deal, ठीक है, मैं इसको दोबारा चेंज करवा दूंगा। यस किसका अब उजैर? हाँ जी आपका क्वेश्चन था उजैर। हाँ जी उजैर।
Sir, I want to ask about shear lag factor. Sir, in the table he has given value for single and double angle for weld 0.8. But if we calculate by using the formula that is 1 minus x over L, then the value may come about 0.99. That is near 1. So which one we should use?
Okay, let me first open the page. Okay. Okay, this was the page. Actually, I will let you know. But I got your question. Sorry, I got your question. What you want to ask? Actually, these are the guidelines to start the design. Okay, you understand me? So actual efficiency is to be determined by this formula. If connection detail is given, then you have to use this formula. Okay, but at the start of the design, if you are want to do certain assumptions, so assumption will be like this. Uzair, you got my answer? You understand?
Sir, at the moment we haven't designed the welded connection, so we don't know we are providing it
No.
diagonally or transverse, something like
No,
that.
no, 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 no. Why you should start designing the weld, because all the weld will be the same. You need to sketch the free body diagram by considering the each member separately connected with the gutter plate. We have already discussed. Please review the connection design, okay? Because at the start, I will just give you the idea. Because at the start, you might have assumed certain value from this table, okay? And after designing the weld, we have considered one example. Let me. Yes. Okay, gentlemen, please hold on for a couple of minutes, 2-3 minutes, okay? Only. So, Uzair, can you hear me, Uzair?
Yes, sir.
Uzair, I'm just showing you the what we have considered. So, you know this table summary. Okay, sorry, Uzair, please. I will, inshallah, today or maybe tomorrow within this week, I will share all the lecture with you. Okay, ODM recording. So that you may revise.
Okay, sir.
So this is the summary for the welded design. Okay, this table I have shared with you. Okay, just see here in the we have solved some examples. I'm just quickly. These are the guidelines we have discussed already. Procedure for the design of the welded connection. Please review it. Okay. Please, I urge you to review it because this procedure is given in your book. So what is the order? Okay, and then if you will have any question, because it will be difficult for me to answer your question if you haven't reviewed the lecture. Okay, so when you will review my lecture, you will have some understanding, and then if I'm responding your question, then you will have you will be able to apprehend my uh, answers. So we had we have solved two examples. Okay, one example was design of the weld for the tension member. If we are having simple tension member, so for stress reversal, I told you that for stress reversal member, you will have the compressive force and tensile force. Whichever force will be larger, you need to design the member for that force. If in the stress reversal member, without multiplying any factor, if the compressive forces are larger, then the weld will be designed for the compressive forces. If the tensile forces they are larger than the compressive forces, then the connection will be designed for tensile forces. So this is the example of the tension member design. So for example, you need to sketch a free body diagram just like this. So this member may be top chord, maybe bottom chord, or maybe diagonal. So it is just connected with the gutter plate. So sketch the free body diagram. For this member, you know the force. So we supposed to use this formula, okay? You need to compute the length of the weld, and the length of the weld is equal to the design force divided by the weld value. So you will compute the design force first, and design force I told you that is the factor tensile force for 50% capacity, whichever is larger. So 50% capacity is 1665 and applied tensile factor force is 300, so Fu is the larger force. And then you need to compute the weld value. For the weld value, you need to decide about the thickness of the weld. We have already discussed. So you are computing three thickness of the weld. So T minimum, T maximum, and T optimum. So T minimum is the function of TP1. TP1 is the thinner plate, that is the thickness of the angle section, and TP2 is the thickness of our bezel plate. So TW maximum is TP1 minus 2. So you will arrange in ascending or descending order, and the middle value will be the our T adopted. That we have used 8. And then I told you that you know the thickness of the weld, you are computing the weld value. So weld value is either based upon the weld failure or base metal. So in that case, so weld value is the lesser value out of these two cases, 1.26. And after computing the length of the weld, which is coming out to be 238 by this formula, so you are computing L1 and L2 because we are using this single angle. In case of the single angle, because the central axis is not in the center, so you are getting the y and d minus y value from the section properties table, and you are computing the L1 and L2. And I told you that you will compare the L1 to satisfy the efficiency. So by using this formula, I told you that you are computing the L1. So this is the connection design, and also we have discussed this example for double angle. Is it double angle? Yes, double angle compression member. In that case, we have to use the L3 also. Please revise this, okay? So I will send you the recording of the ODL lecture, inshallah. For the design part, at least I will share the lecture, inshallah, by tonight. And rest of the slides, recording of ODL lecture, I will share gradually. So please revise it. Yes, Uzair, any other question? Any questions, gentlemen? So no one is having the question. Uzair, are you there?
Yes, sir.
Okay, so should I start the today's lecture?
Yes, sir.
Okay, before starting the today's lecture, I will quickly, maybe just passing the slide until what extent we have covered this. So next, actually, we have started the riveted and bolted connection. So similarly, if we design formula will be the same, just similar to the welded connection design. But instead of using the welding or welded material, we have to use the fastener. Fastener may be rivet or maybe bolt for the connection. And then just like in the welded connection, we have discussed that what are the possibilities or type of the failure that may occur in welded connection design. Because the strength of the welded connection, based on the strength of the welded connection, we have computed the weld value. And these values we have computed by two formulas, which are based upon type of the anticipated failure. So welded connection, either the weld may fail in shear or the thickness of the plate along the length of the weld, it may be teared or torn. So it means that we have determined the weld value either the based upon the weld failure or base metal failure. And the least value is the weld value. Similarly, we need to see that or check that what are the possible failures in case of the riveted or fastener connection. So first of all, we have to understand that what are the type of the stresses are being produced in riveted or the welded connection. So I gave you the example that we are having two plates which are connected by the fastener, and if they are being applied with the tensile force, maybe this plate is being pulled on this side and this plate is being pulled on the other side. So two type of the stresses are produced. So one possible failure is that this bolt may break from here in between the intersection or the interface of two plates. So if the bolt will fail, so this will fail due to shear forces or shear stresses. So because these forces, they are acting parallel to this area which is failed or broken, because this applied force was parallel to this force, it means that the first possible failure is that bolt may failure due to the shear forces, and the shear forces will be equal to this applied force. And other, if the bolt thickness diameter is very large and applied stresses are less than the shear strength of the bolt, then it will not fail. Then other stresses which are acting are the bearing. Bearing means that if I am pulling this plate to other side, so the opposite to this force, the area or only the area which is surrounded by the bolt on the other side, it is resisting all these stresses, the plate. So this plate area whose length is equal to the thickness of the plate, and diameter we can assume that length width we can assume equal to diameter. So this plate is resisting all these stresses, and these stresses are only acting on this small portion. So we are referring these stresses as a bearing stresses, because this plate is bearing the stresses due to this applied force. So it means that if the stresses on this one side of the bolt through the thickness of the plate, if these stresses are more than yield stresses, then deformation will occur here. So the size of the bolt will become extra, because due to the yielding of the material, the hole size will become more than this diameter of the bolt, and the plate may come outside. So we have to understand that when a bolted connection is subjected to forces, there are two type of these stresses which are being produced. One is the bearing stresses on the opposite face of the bolt or one side of the bolt, and shear stresses in the bolt. Okay, if these forces are compressive, then the bearing stress will be on this side. For example, if this force is compressive, then the bearing stress are acting on this side and on the bottom plate on this side. But anyhow, whether the force is tensile or compressive, so bearing stresses are acting on the one side of the bolt or the fastener, and the area of the plate which is resisting that stresses is having the area whose thickness is equal to thickness of the plate, and the width is equal to the diameter of this bolt, because the stresses at the junction is not distributed to the entire plate area, only to this local area. So that's why these stresses are called bearing. So these stresses which are bearing, that should be less than the yield strength of the material. Otherwise, the size of the hole will be increased or extended, and the plate may come outside the bolt. So this I have explained. So we need to compute the rivet value. So rivet value is the strength in kilonewton load carrying capacity of a single bolt, which is either based upon the shear failure or bearing failure. And I have discussed there are different type of the bolts which are available in the market. M15, M18. So M mean that metric bolt. So their M15 mean that their diameter is 15 millimeter, and they are made as per two standard: ASTM standard 325M and A49M. So if, for example, we are having M20, M20 means a bolt whose diameter is 20 millimeter. So if it is made as per this specification A325M, So its shear strength or the pre-tension tensile capacity is 176. And for a 49M, that capacity will be 179. And that is the diameter, the hole that we need to punch. We have already discussed in our tension member design. So further, I have explained the concept of pre-tension.
Excuse me, sir. Sir, video start kar dein recording.
Okay, I will start because this is just I'm the fresh lecture. I will start. Okay, video recording because I have already covered this in my previous lecture. This is I'm just revising it, so I don't want any duplication because I have already recorded this part. Okay, मैं फिर भी कहते हैं आपको start कर दूंगा थोड़ी देर में, ठीक है? मोइन मैं just start होगा
Okay, sir. Thank you.
मैं चला मैं आपको रिकॉर्ड करूंगा, ठीक है?
Thank you.
अच्छा, okay, you are saying. इसके बाद we have also discussed this table. So there are different type of the boards available in the market with reference to their strength grade. So we may have A502 grade 1 and A502 grade 2 and grade 3 or the river. So these are type of river that we may use for the connection. And this is the A307 bolt. We may have the A325M bolt or A49M bolt. And their strength is already provided. Okay, please, gentlemen, mute your mics. Mute your mics. Okay. Or I have to mute. Okay. So tensile strength of normally if we want to use the rivet, we use A502 grade 2 or grade 3 hot rivet. And for this board, tensile strength is 400 megapascal. And the strength reduction factor is used as a 0.75. And the shear strength of the same bolt is 228. So if in the examination you are given that use A502 grade 2 or grade 3 hot driven rivet, then you can consult this value from here. And I believe that this table is also provided in our LRFD design aid, maybe page number with me is अगर कोई ढूंढ के पहले मुझे बता रहे मैंने लास्ट टाइम यस पेज नंबर 88 पेज नंबर 88 मैं आपको बता दूं आपको यू डोंट नीड टू मेमोराइज इट पेज नंबर 88 this page is 86 yes on page number 88 this table is so in the examination you will be just given this statement use A502 grade 2 or grade 3 hot driven so you can consult the page number 88 on LRFD design aid and you can get its shear strength. So shear strength if I divide let's suppose 2 to 8 that is around 0.55 so it is assumed as a 55%. So later on in the previous lecture I have told you that normally the shear strength is considered 60% of ultimate strength but that is a rough calculation but actually we will discuss also in structural mechanics class in our next semester when you are taking this class with any teacher he will let you know the exact pattern but here you will come to know that the shear strength is considered as a 55% of 414. So if you are multiplying 414 into 0.55, so you will have exactly the answer 228. So again, Fu is 825 megapascal. Okay, here, just understand what is mentioned over here. In case of the bolt, actually, this could be the quiz question, okay, gentlemen? I can ask this question in quiz. In case of the rivet, we are considering the complete tensile strength. But for A30, A325M bolt, this bolt is having ultimate strength 825 megapascal. But in the tension member, if the bolt is in tension, we are considering the tensile strength of the bolt 620, which is 75% of Fu. Why we are considering 75? Because in case of the bolts, we are having the helix, where actually we need to tighten the nut through helix. So we are assuming that if bolt is in tension, so the helix, it may be broken from the helix, or where it is having the thread. So threaded area, we are assuming it is 75% of the area where we do not have any thread. So in case of the tension, bolt may always fail from the threaded portion. So that's why tensile strength is considered as a 75% of 620. But shear strength is considered 40% of Fu, 40% of not this, because the threaded portion will not be available at interjunction. For example, I will explain. Yes. For example, you can say this is one plate and this is another plate. So if the bolt will fail in shear, so it will fail from here. So here we are not having any threaded portion. Threaded portion is only on the one side where we need to tighten the nut. So at the junction, we will have the complete or solid area of the bolt available without thread. So that's why we are considering the ultimate strength as a 40% of Fu. But anyhow, you can consult this table for shear strength and ultimate strength. Then we will discuss this thing. Okay, I think we need to start from here, for today's lecture. So would you mind to have some break at the moment, gentlemen? How many students want break? Raise the hand. ठीक है, सबको break चाहिए. Okay. Listen, because I have to offer Zohar prayer. So I will start the lecture at 2:25. Okay. So around maybe 23 minutes. So the time is 8 minutes to go for the 2 p.m. So I will start the lecture at 2:15. Is it okay? And because after that, because we need to start the new topic, and I will also start the ODL lecture. So I will mute. I have to start from here. So let me copy one slide from. Okay, Bismillahirrahmanirrahim. Before starting the lecture, let me start recording. Bismillahirrahmanirrahim. Dear students, inshallah, today we are going to discuss the type of the stresses which are produced in fastener type of the connection. Fastener type means either riveted or bolted. And depending upon or the based upon these stresses, how we can compute the stress or the strength of this fastener type of connection. So you will see, you have already seen a lap type of the connection in the figure 8.28 that we have already discussed. And here we discussed that whenever a fastener type of the connection for a two plates, they are connected with fastener, they are subjected to compressive or tensile forces, then two type of these stresses may produce. Number one is the shear stress, or the failure may occur at the plane of shear or at the interface of two plates, or we might have some bearing failure or the bearing stresses which are acting on one side of the bolts in any plate. So the cross section at which the different layers of fastener try to slide against each other, and failure can occur here. So the shear failure may occur between the interface of two plates because they can slide. So they can only slide if the bolts or the rivet fail through that plane, which is referred as a shear plane. So in that case, the failure will occur due to the breaking of the bolt, and the diameter of the bolt will be broken. So the cross-section area which actually resisting the shear force in case is equal to the cross-sectional area of the bolt, which is equal to pi d square by 4. If we know the diameter of the bolt, so we can determine the resisting area or area which was resisting the failure. So failure may occur through the cross-section, and cross-section area can be determined by pi d square by 4. That is the diameter of the rivet. However, in case of the bolt, there are two possibilities. Bolt will have more strength if failure plane lies in unthreaded portion, and less strength if the failure plane lies within the threaded portion. So how I can explain? Do I have some pictures? Yes, I can explain from this picture. For example, here we are having the bolt, and here we are having the thread. So actually, there are, you can say that in this case, 1, 2, and 3 plates, they are connected with the bolt. So it means that failure may either occur at the interface of the top plate and middle plate from here, or at interface of middle plate and the bottom plate. For example, if you say that at this interface, we are having the threaded area, and at this interface, we do not have any thread area, then the failure will occur from here, because at the threaded portion, the cross-sectional area of the bolt will be less, because due to threads, we have cut some metal. But if at all possible plane, where the possible failure may occur, do not have any threaded portion, then the strength may be same at all sliding planes. For example, you can see that the threaded area is below this interface. So at this interface, only the solid portion exists, and also at this interface, we do not have any threaded portion. So the shear stresses produced at this interface and at this interface will be same. But if threaded area exists, so if the less area is available, so intensity of the stress will be more. So failure may occur at this point. So we will discuss it again one by one. So effective area of cross section resisting shear. In the later cases, shear mean in the threaded portion. So we can consider that shear strength is, or the area of the threaded portion is approximately 75% of the total area. So we are subtracting 25% of the area due to the grooves or cutting of the metal to make the threads. However, adjustment for this reduction is made in the strength, and then area calculated on the base of outer diameter is used to evaluate the strength. So we will discuss it when we are designing the our connection, how we can adjust the stresses. Because the fastener and plate are not fully joined with each other, the forces from the fastener are transferred to the plates by bearing stresses in the plate in the plate material surrounding the bolt on the one side, as you have already seen in the figure. So here he's want to say that because in the previous figure, where was that figure? Here, yes. Because here this T force is uniformly distributed on the cross section. But at this connection, so this plate is only connected with this bolt. So it means that at this point, only that contact area of the plate which is directly in touch with this fastener is resisting the force. It means that this tensile forces is transferred due to this contact area, which is called the bearing area, to this bolt, and then from this bolt, the force is transferring to the other plate. So this will only possible if the bolt itself safe to fail in shear. So it means that either this plate may fail due to the yielding of this material because it is transferring the stress, and the area of this plate which is transferring the force from plate to the bolt is having the area whose length equal to the thickness of the plate and width is equal to the diameter for the approximate calculation. So bearing stress, how we can compute that bearing stresses which are produced in the plate within the contact area of plate and bolt. So bearing stresses are very high, but local compressive stresses produced when two surfaces about each other and they are acting two surfaces abut means they are meeting with each other and transfer the load. If sufficient material is available around the zone of high bearing stresses, then these stresses quickly spread over a greater region, then reduce the intensity. The local stress material is confined in nature. So uh, for this reason and for the reason that the local compressive stresses cannot produce fracture and buckling stresses up to 3 per time of the ultimate strength can be assumed. Okay, let me explain this thing, what he want to say. Let me explain from here. So in this diagram, let me sketch some areas. So you may assume that, just for your understanding clarity, I am assuming this is the area which is subjected to bearing stress, and let me change the color, maybe remain the same. Okay, please, gentlemen, hold on. I was explaining. So just assume that it is better to change this color. Let me use the red color. So just for the clarity, bearing stresses are only acting in this region, and the area is having the length or the width equal to diameter, and the thickness is equal to thickness of the plate. So it means that only this area is resisting or complete force. At this point, for example, if I sketch a line over here, let's suppose maybe at this cross section of the plate. So at this cross section, so total stress will be equal to T divided by this area. So you know that already. If I am having some equation from any previous. So you can say that the stress that we are denoting as a F is equal to P over A. And let's suppose I'm calling as a A1. And similarly, let me use T because T is the force acting. And that is the A2 and that is the A1. And you may consider that A1 is this area, and similarly A2 is the area, this red area, which is under bearing, which is resisting all the force, that is A2. So T is the same. So what do you think? Because F1, let's suppose, just to understand more, I'm referring as a F1 and I'm calling it as a F2. F2 are the stresses produced in this bearing region and F1 are the stresses which are produced in the plate. T is the constant. So F1 will be less because A1 is larger. For the same tensile force which is to be transferred from this plate to this bolt, and only this area of the plate which is in contact with this bolt is transferring the load, not the entire plate. So this area is the bearing area which is very less, which is A2. So A2 is very less as compared to the A1. It means that F2 stresses in this bearing region or the plate area which is in contact with the bolt is more. So is very less as compared to the total area of the plate. So it means that the F2 will always be larger than F1. So if T is increasing, so there are chances that F2 will approach to the yield value first. So due to the very less area, so this material may be yielded. But at the same time, you may consider that so yielding is occur only at this very small portion, and this area is in compression. And you will see that, let me consider some material on the three sides. So on the three side, let's suppose one side top and one side bottom and one side at the maybe three. So it means that the material which is yielding, it is surrounded from all the three sides, not from the four, because on this one side, four side, we are having bolt. This material is not yielded because this material is still in the elastic range. So what happens when this material is yielding? Due to compression, this material will tend to shorten in width. So if material will shorten in thickness, so it will need to expand in the later direction. But it will not expand. Why it will not be expanded? Because this yielded material is surrounded by the elastic material from the three sides or confined by material which is not subjected to stresses. this material which is on the sides of this yielded material will not let this material to deform. So what happened? This is called local confinement effect. What is the local confinement effect? When a very small portion of the plate is yielded, or if the localized compression yielding failure occur or yield stress occur, so material after yielding tend to expand or move in the lateral direction, but the surrounding material which is still in the elastic range will not let this material to move in the lateral direction. And this phenomenon is called the local stress confinement. So this phenomenon actually increase the load carrying capacity. How it increase? I will give you a very simple example, maybe I have already given. If you are having one sponge or foam, if you want to compress, you can easily compress it. But if you ask somebody to place the hand on the both side of the foam, top side and the bottom side, if you want to compress it, you need more force. Why? Because its lateral movement has been confined. So when a material tend to deform and there are some constraints available against its movement or the deformation, and this confinement increase the strength. So this is called the local stress confinement, because yielding will occur only in this red zone, and this green zone, they are still in the elastic range, so they will not let to deform this body. So it means that this failure will not be occur due to yielding. Only the failure will occur if the stress is more than the ultimate stress. So if the stress, even though the stress is more than ultimate stress, only the crack or the rupture will occur only in this region. But most of the plate region, that will be remain safe. So due to this reason, the stress, he says that due to this reason, the ultimate strength is considered as a 3 time of Fu. So we assume that due to the bearing, the strength is equal to 3 time of the ultimate strength, because the failure will only occur if applied stress will be 3 time of Fu. Why 3 times? Because it is surrounded by elastic material from the three sides. If this material, this will also yield or break, then the failure will occur. Then there is a one further thing. He says that there are two formula to compute the bearing strength, or there are two possibilities of the failure. Number one, let me sketch this diagram. Control A. And let me copy this formula here. And I need to copy this diagram again. And we want to consider some bearing strength. Actually, that is the function of the clear edge distance. What is the clear edge distance? That is this value. You can say that from this edge so here, and this value is, you can say that the distance from the edge of the bolt distance from the edge of the side of the bolt to the edge of the blade, it is referred as a LC, clear length or edge of the bolt available. We are referring as a LC. So this distance is referred as a LC. So what this distance is representing? Because formula to compute the bearing strength is different. So the first case, when deformation at bolt hole due to service load is considered, then the normal bearing strength, service load means that without being multiplied with factor of safety. Actually, I'm not going to discuss this formula because this is the formula for ASD method. So ASD method load carrying capacity is equal to 1.2 time of the LC into T and FU. And how it is computed, I will explain. So actually this slide is for the ASD method. So, but we are rather discussing this slide because we are considering the design strength. So let me introduce the formula again here. So the formula is stress is equal to applied load, and you can say that that is the, maybe you can say which he has used. Okay, I'm instead of the T, I'm assuming that applied load is RU, or you can say. And from here, for nominal capacity, bearing capacity, you can say that that is the Rn. So if you want to compute the Rn value, so Rn value will be equal to F into area under bearing. So this value we can use, this may be Fu or Fy, and area under bearing, what value we have to use. So let me copy this formula also here. So there are two conditions actually. If LC is less than 2 times of the diameter. So what LC I have mentioned? If LC, this clear edge distance, is less than 2 times of this diameter, then what it means that we are having very large edge distance. Then in that case, instead of this bearing failure, because edge distance is very less, plate may be torn from here. Torn maybe it means that you can say the failure will be occurring from here. This tear failure will occur. So again, what I want to explain, so there might be two types of the bearing failure, which are the function of this clear edge distance. If clear edge distance is less than 2 times of the diameter, then the plate will be torn from this end. So in that case, capacity will be computed by this formula. 1.5 times of the, this is the area. So let me put in the bracket. So what area is will be used to compute the strength, or which area is resisting the stress? So LC into T. So it means that if the failure will occur from here, so we have to consider the failure area. So failure area will be equal to LC because this plate will be torn from here. So area which will be torn is equal to this LC into thickness of this plate. Again, if the tear failure will occur, then the area that will be torn will be equal to this LC length into thickness of this plate. So it will be 1.5. So we have to use the 1.5 time of the nominal strength. So nominal strength will be 1.5 times of the area which is resisting the bearing stress into the FU. Why we are considering the stress FU? Because failure will occur due to the tearing of the plate, and tearing will only occur when the applied stress or the applied uh, stresses are more than FU. But second case, if LC is more than 2D, LC is more than 2D mean that if this LC is very large, it is more than 2 times of the diameter, then the tearing failure will not occur. Then only this region which is red, it will be yielded only. When it will be yielding, so due to the yielding, deformation will occur only one side of the board. So hole will become oversized. It means that the opening of the hole or the diameter hole will be increased due to the local yielding of the material. So this is the failure will occur. You can see that on the one side, the hole size has increased. So due to the local yielding, actually the plate will not be broken, because when the hole size will become larger, so the plate can come out of the bolt or the rivet easily. So this you can say that tearing type of the bearing failure, and that is the you can say that opening of the holes due to the bearing failure. So depending upon the case, we are having two formula. Number one formula, the capacity, the load at which the tearing failure will occur. This formula will be used if clear edge distance is less than 2D. So then the strength is 1.5 times of the LC into T into FU. And if LC is more than 3D, then in that case, area of the yielding will be used different. In that case, area of the yielding will be diameter into thickness. Just I have explained. So area which is yielding is having the width diameter, and the thickness we have already discussed here, because this area is yielding. So the length is equal to thickness of the plate, and all the smaller plate. If the two plates are having the same thickness, then any thickness may be used. Otherwise, thinner plate will be used. So area will be different. So where we were. So here we were discussing the two type of the failure. So depending, so why we are using these three? Because the bearing failure will only occur if the stress will be 3 times of the FU due to local confinement effect. Here the confinement effect is just considered as a 50% more, but here 200% more than the FU value. So depending upon the clear edge distance, we have to investigate the bearing strength. And 0.75 will be the factor, strength reduction factor. So we need to multiply this equation with 5 value to compute the design strength. Okay, next is the shear stresses. So the shear stresses may occur in the bolt at the interface. So depending upon the number of the plates, we may have the single shear or we may have the double shear failure. So the type of the shear is called, for example, when two plates of a lap joint are pulled in opposite direction, only one failure plane is produced, and the fastener strength is determined by the one cross section only. And this type of the failure is referred as a single failure, or we are having only one shear plane. But if more than two plates they are connected with the same board, then the number of the shear plane will be more. So it means that applied load may be resisted by two shear planes. So number of the shear plane normally equal to number of the plates minus 1. So you have, I believe, that already studied the concept of single shear and double shear in strength of material. So here, so we are having two plates which are to be connected by the bolt. So there is only one plate which is resisting. So only one interface or sliding may occur only at one sliding plane. So this means that one bolt, it is resisting the shear stresses only at one plane. So if we are connecting three plates, then we are having two planes where the sliding may occur. So one bolt, it is resisting the same force at two places. So it means that one force, total force T is being resisted by one area here. But here, total T force is being resisted by two areas. So it means that the capacity of this bolt will be more as compared to this, or the stress in this case will be half because number of shear planes are more. So if you want to modify this formula, so you can say that if I want to compute the shear stresses, let me represent as a tau. Okay, let me use the same symbol. We can change it one. Or simple, let me V, shear stresses. Or okay, these are shear stresses which are equal to maybe shear force over V. So you can further multiply with the N value. N is the number of shear planes. You can call it total NS or maybe. So more will be the number of the shear plane, less will be the shear stresses. So that is depending upon this case. So here you can see that I have given example how the shear failure may occur. Three plates, they are connected with the fastener, and you can see that due to sliding, rupture failure occur here, shear rupture, and also shear rupture will occur here. If the plate is strong enough in bearing, so it will break from here. So that is a double shear. So I will stop over here because I have one urgent work. So next time we will start from here. So anybody, if you are having any question, you can ask me.